Hello, my name is Dan Grissom. I'm an assistant professor at Azusa Pacific University. In this tutorial, I'm going to show you guys how to set up a development environment for the Microsoft Assembler, or Microsoft Macro Assembler, MASM for short, if you're unfamiliar with the term. And we're also going to create our first MASM program. So many of you guys, I suspect, may be coming to this video because perhaps you're taking a course specifically using Kip Irvine's Assembly Language for x86 Processors book. If you are, that's great. If you're not, I highly recommend that book. It's really useful if you've never done x86 assembly code. So I'll actually be using his installation instructions as a frame of reference, kind of skipping over some of the less important stuff to kind of get us up and running, and maybe adding a few extra tips as well. Okay, so with that said, the first thing we need to do is, well, let's go ahead and load up that page. Okay, so let's go ahead and load up that page for where you can find these kind of base reference instructions in case you need them to kind of help. So I'm going to just Google Kip Irvine ASM. Click on that first link up there. And then go ahead and click on it. You can see there's a number of helpful links here, but go ahead and click on the Visual Studio 2015 link. And you'll see a really long page with lots of instructions in there. Okay. So the first thing we need to do to get started is to download the IDE, the Integrated Development Environment. Okay, so we're actually going to use Visual Studio, as you can tell by now. There's a number of different IDEs you can use, so if you just open up a Google page again, and just Google MASM, you can go to the Wikipedia page to kind of get a brief overview of some other IDEs in case you want to maybe try out a different one, but being a Microsoft product, the MASM, we'll go ahead and just use Visual Studio, Microsoft's Visual Studio. Okay, so with that said, let's go ahead and download Visual Studio. So go ahead, just Google Visual Studio. Click on the first link, and we will go to Downloads, All Downloads. Okay, and we'll go ahead and grab the latest one. Okay, so we're working in a Microsoft Windows 10 operating system, and we'll go ahead and grab the latest Visual Studio 2015 as of January 2016. So there's a number of additions. I'm going to go ahead and grab the community. I think a number of these would work, but we'll go ahead and grab just the free community edition. So just go ahead and click download on the web installer. It's going to download a very small file, which in turn is going to open up and download many more files. So go ahead and click on that, or wherever you download it, go ahead and open that. And it's going to give us a warning. Kind of wait for that to open up. Okay, so it's going to basically give us some options. You'll see where it's going to install to program files, x86, Microsoft Visual Studio 14.0. I'm going to go ahead and click Custom and just click Next. So the assembly language is kind of going to run in the environment very closest to Visual C++ compared to some of this other stuff. So I'm going to go ahead and click Visual C++, and I'm going to kind of uncheck all this web development stuff. We don't really need it. So Visual C++, I'll go ahead and just click that. That's fine. And click Next. You'll see this is actually going to take quite a while. It's going to be requiring 11 gigabytes. So go ahead and click Next. Click Install. Yes. Okay. At this point, I'm going to pause the video while this runs. This will take a while. I'll let you know how long it took as soon as I unpause it. Alright, and we are back. It took about a little over 12 minutes to download and install that. The internet connection here is fairly quick, so if you have a slow internet connection or a slow computer, that could take a lot longer having downloaded. It sounds like roughly 11 gigabytes on that particular installation. One thing I will kind of caution you about is make sure that you're not doing any Windows updates or haven't done any Windows updates recently. Before restarting your computer. I've seen that can dramatically impact the installer and even cause it to basically freeze and have to restart. So just kind of keep an eye on the Windows updates. Try to make sure those are all done and not running when you do this Visual Studio installation. All right, so with that, we can go ahead and launch the application. Let's see what happens here. Maybe it's launching me a new web page instead. Okay, so we don't really need an account for this. Select your theme, whatever you prefer. I'll just set it up to Visual C++ as the particular development settings. Start Visual Studio. This may take a few more minutes. As we wait. There we go. All right. So we now have a version of Visual Studio installed, which is a good first start. We now need to create an assembly project, which is not super intuitive. It's not super intuitive to create a MASM project. So if we go back to the installation instructions, we can get rid of our Visual Studio pages now. If we go back to our Kip Irvine instructions, you'll actually see that he shows you way down here. Let's see, way down here. Here it is, creating a 32-bit project from scratch. Shows you how to do it, but as he's also demonstrating, this is a pretty intense process. Lots of settings to do, and some even in there for his particular libraries. So what's nice is this is not something we really want to do often. And this installation page actually has a project for you, okay, with a demonstration assembly file. To get us started. That way we don't have to go through all that that process of setting up the particular settings for MASM. So if you kind of come down to this tutorial, building a 32-bit assembly language program, you'll see right-click here to download a zip file. So go ahead and just click that to download it. And wait a second for that to download, and you'll see that'll open up a zip file. So what I'm going to do is I'm just going to create on my desktop for now. You can do this wherever you want, but I'm just going to create a folder, assembly code, or whatever you want to call it. It doesn't matter. Okay, and I'm going to go ahead and I'm going to move this entire folder in there. So just kind of unzip it. So if we open up the assembly code folder, we'll see that that project folder is in there. If we open that up, you'll see a few files. You'll see project.sln, that's the solution file, the Visual Studio solution file. You'll see the VC project file for the particular project in that solution. And then most importantly, you'll see the add2.asm. So this is a very simple assembly language file. So let me go ahead and just open that up with Notepad or something like that. Okay, so see it has some basic instructions, a move and an add, as well as some other kind of pieces of code that just kind of need to be there. Okay, so not a whole lot going on in this file, but it should be enough to give us a demonstration of getting our code to work. Okay, so what I want to do is I want to go back to my Visual Studio, just kind of close the start page, and I'm going to go ahead and load that solution space. So go ahead and say open project or solution, and then go ahead and find wherever you had your those files you just downloaded. So for me, it's on my desktop in assembly code, and in that project 32. So go ahead and just click project solution, and then click open. Okay, so we'll see a number of different things here. You'll see the project called project, and you'll actually be able to see this add2.asm. We can go ahead and double click that to open it, and you'll see the same code we just saw. Okay, so the first thing I want to kind of point out is that notice that typically when we think, what's one of the great things about IDEs such as Eclipse and Visual Studio is something called syntax highlighting. Right? If I'm writing an if statement or a for loop, typically in these different IDEs, those keywords will change colors because your software knows that those are special words. Here we see everything's black. MASM is not necessarily a super popular use of Visual Studio compared to C++ and C#, things like that. So what we need to do is actually add the ability to understand MASM syntax highlighting to Visual Studio. So there's two ways we can do this. I'm going to show you the first way, which is probably a little bit better if it works, and if this doesn't work for you, I'll show you the second way that should also add some highlighting. Maybe not as much highlighting, but still a good amount. So go ahead and go back to the Kip Irvine page, and you'll want to basically scroll down until where you can search for syntax, and you'll see at the very bottom MASM syntax highlighting. Essentially, there's a user type.dat file. It's actually a zip file. So go ahead and just download that. Okay, I'm just going to move this out of the way for a second. Okay, so what I want to do now is I'm going to unpack that user type.dat just to my desktop for now. Okay, I'm going to go ahead and move this file to my file system inside the folders for Visual Studio. Okay, so the place I want to do this, go ahead and open up my computer, this PC, go to the C drive, program files x86, and then you'll scroll down to, we happen to be working with Visual Studio 2015, which is this Visual Studio 14.0 folder. Once you're in there, go click on Common 7, go into that folder, and then into the IDE folder. Okay. So this is the place where we actually want to dump that file. Okay, so go ahead and just grab user type.dat and just move to IDE. You'll have to click Continue most likely, since this is it's kind of a special folder. Okay. All right. So once you're in there, let's go ahead and I'll just minimize that for now, so I'm sure it did the right thing. I'm going to come back to Visual Studio. Okay, I'm going to go click on Tools, Options, and I'm going to scroll down until I see Text Editor. I'm going to expand that, and then I'm going to click on File Extensions. Okay, so essentially what I need to do is kind of add that user data type file to the ASM file type. So go ahead and just I'll click on Visual C++, and I'll just type in ASM because if you recall, that is the type of file that I have. It's an ASM file. You can see it right there as well. Okay, and I'll just simply click Add. Okay, and with that I just click OK, and then I just want to close Visual Studio and then reopen it. So I'll just maybe click on the Start button and type in Visual Studio. Click on Visual Studio 2015. Okay, so I'm going to go ahead and open, let's see, recent projects. So I'll go ahead and open this project.sln that I already had open. And if everything works properly, you should see that now we have a little bit of syntax highlighting. So things like move and add are now highlighted blue, as well as EAX, some of the registers, and some of the other kind of keywords here. Okay. All right. So if that does not work, that should work for most everyone. If that does not work, another way to do this is bring back my folder here, or my web browser. On Google, go ahead and just search for MASM. Actually, search for ASM. There it is, AsmHighlighter. See, a number of things will pop up. This first link is good if you have an older version of Visual Studio, but if you have the newest version, you actually want to come down here to Visual Studio Gallery. Go ahead and click on that, and you'll find the AsmHighlighter, which is free. So at this point, you would just go ahead and download this. It's kind of like an installer. Actually going to run through, but if I click on it, hopefully it'll give me an option. You would just go ahead and click install. You'll see it recognizes the version of Visual Studio you have. So you would click install and then go ahead, run through that process. Real simple, real fast. and then go ahead and restart Visual Studio at that point. Okay, so let's go ahead and run some code here. So we'll run our first assembly language program. So all I need to do now is click build. I can build a project or solution since I only have one solution. So click build solution, and you should see some output down here. Hopefully, well, we get an error. Let's see. Okay, so we have this error, and if you kind of go down and look at the error, you'll see we will see somewhere it said Irvine library. Okay, sorry, I accidentally compiled once without demonstrating that. So I'll go ahead and compile just that same code that we had from the beginning. And you'll see basically it has this linking error. It says cannot open file irvine32.lib. Okay, so essentially we actually kind of skipped over one important step of downloading the libraries for basically Kip Irvine has a group of libraries, basically code that we can use that will make kind of the learning process for x86 a lot easier. So what we're going to go ahead and do right now is we'll go ahead and open up the assembly language website again, and basically we want to scroll down until we see right here installing the book's example program. So click this link to get the latest copy of the book's link libraries. Go ahead and download that. And so we have 2015. So we're going to go ahead and just download the one. It says 2012 and 2013. So we'll go ahead and download that one since it's the latest. You'll see that will download an installer of sorts. As soon as that's done, we will click it, go ahead and run it. And I would recommend just using the C Irvine folder. They have that earlier project that we downloaded, the earlier Visual Studio solution project, has some settings in there, hard-coded, I believe, that know to look for this particular directory to get access to these libraries that we'll commonly be using. So go ahead and just leave that what it is, even if you're tempted to organize things in your own way. Just click next, yes, and then close. Alright, so let's try this one more time. We may need to restart, but we will go ahead and build the solution. And there we see that we get a success this time. So what I'm going to do now is I can basically click Start Without Debugging, and you'll see that will bring up a folder that says press any key to continue. Okay, so the program actually ran whether we really realized it or not. It's not really outputting anything to the screen. We'll say press any key to continue basically when it's done. So what I want to do is just close this, press any key. Okay, and one important thing with debugging one important thing with assembly code is learning how to debug. If you've used Visual Studio or Eclipse, you're probably hopefully somewhat familiar with this process. But let's go ahead and set up a breakpoint right here on this move EAX. There's really only 2 or 3 real instructions in this program. You can see, kind of like with Java, I have a main, and then I have a few instructions inside of that main. So I'm moving 5 into this EAX register, and then I'm adding 6 to whatever's in the EAX register, which is 5, and I'm saving that result into EAX. So we can actually trace this in our debugger. So again, go ahead and double click out here. You'll see that big red dot pop up, and then you can click up at the top, and you can say Start Debugging. And this will run our program, but it will actually stop in the midst of our program. So you can see a few things right here. You can see down at the bottom we have these autos. This will tell us what's in our register. It'll tell us essentially, this is really important, the value in there, which right now it's kind of just gibberish because we haven't actually run this instruction. And it'll show us the unsigned int, the data type. Okay. So if you want, you can right-click on this whole area and click hexadecimal display, and then it will show you the hexadecimal version of what's actually in that in this variable or this register, so to speak. Okay, so I'll uncheck the hexadecimal display. Typically, we want to maybe look at all the registers as we're running. So if you click on the Debug menu, click on Windows, and then come over and click on there should be registers at the very bottom. That'll bring up another view, and it might have already been up down here. If I click locals, registers, autos. So there's autos and then registers down here. And then we can actually see exactly what's in these particular registers. Okay, so again, here's my locals. Do hexadecimal. You'll see that it's the same thing. So here's my EAX, A2FF02, and so on. If I go to autos, you'll see it's the exact same thing, but I can now see the hexadecimal display. Under registers view, so you can see all the main registers, you can also right click and see the flags. This may not make much sense to you now, but eventually it will, so it's good to know that you can do that. The other thing you'll probably want to see is the output, so I would go ahead and click on output down here if you want to basically see what's being output to the screen or to the console at any given time. If that tab was not down there, you can click debug, Windows, and then output right there, and that'll bring that up for you. Some of this other stuff you can probably remove. You probably won't need it too much. You can leave it up there for now, get rid of it, whatever your preference is. So let's go ahead and now run a command. Okay, so I am going to click step over, and you'll now see that EAX is holding 5 hexadecimal. If I go to autos, you'll see that the value is 5 as well. Now I'm going to add, so I'll do this one more time. And I'm going to say basically 5 plus 6, you'll see EAX has 11, and hexadecimal, that is B. So 11B. Registers, you also see that same thing highlighted. What's really nice is the value will turn red if it just changed. So if this last instruction that we ran caused the value in EAX to change, you'll see that that will change. So you also see that the ZR flag and the PE flag just changed as a result of that add instruction. The EIP, the EFL, and the EAX also changed. Okay. All right. So with that, you've basically created your first assembly program, or at least you've run your first assembly program. So what I want to do now is I want to use the Kip Irvine library to essentially maybe do some very, very basic instructions that you may not learn for a while, but it would be really good to know from the beginning, and kind of create maybe like a little bit of a rough template file for us to be using. I also want to show you how to run 2 assembly language files from the same project. So it's a little bit difficult to, in Eclipse, if we're working with Java, we can have multiple files with mains in them, and kind of whichever one happens to be open, Eclipse will run it. Can't really do that here. So let's for instance create a new assembly file. Okay, so I'm just going to go ahead and right click on my project, and I will say add new item. Okay, so there's not really an ASM file type here, so I'm just going to click on CPP, and then on the name I'll go ahead and say first program or something like that .asm. Okay, so remember ASM is the assembly language file type. So I'll click add, and now I'll add a new ASM file type, a new ASM file. I'll go ahead to my add to, and I'll just go ahead and copy and paste this whole thing into first program. Paste. Okay, so I'll just change this a little bit, right, so we can kind of just see what's happening. I'll add 1 and 2 together. I'll save that. So what happens when I actually try to run this now? Okay, if I just say build project, well, I'm debugging, so yeah, go ahead and stop that first. You'll see that it fails. If I look at the error, it says fatal error, 1 or more multiplied defined symbols found. Okay, essentially, it's just not happy that I have 2 mains. Right here, you can see main already defined. That's the real problem. We have a linking here. Okay, so essentially what I need to do is I need to get rid of one of these mains to run the second one. So this is kind of a pain. I know in Eclipse we typically have everything. We can have multiple projects, and we could have multiple projects, but the problem is it's actually very difficult to create an assembly project. You saw from the Irvine page, he has the instructions if you do want to do this. if you go down to building, not building, but I think down here, creating a 32-bit project from scratch, you could actually do this on your own. See, it has 14 steps, so there's a lot to it. You probably are not going to want to do this very often. So what I'm going to do is just kind of a simple workaround. I'm going to go ahead and add to this solution. Okay, I'm going to add a solution folder. I'm just going to call this my ASM library, right? You can add however many of these you want. But essentially what I want to do is I just want to kind of get the ASM file that I'm not working on right now kind of out of the project space. So this add to, I don't really want to be working on. I want to now be working on my first program. So what I'm going to do is I'm just simply going to drag this up to ASM library. You'll see it's basically now in 2 places at once. It's the same file, but it's just kind of the reference. And then what I'm going to do, you can see if I try to run this, it's still going to give me the same problem if I say build project. Okay. So what I want to do now is right click on add to and click exclude from project. Okay, do not click remove. If you do, it's going to give you the option of actually deleting it, which you don't want to do. Obviously, you want to keep that file. So I would always just click exclude from project, and you'll see that way you'll be left with just your new program that you want to be working on, and you kind of have your ASM library up here. Now, obviously, you can make a bunch of folders in your solution if you want to organize chapter 1, chapter 2, lecture code, however you want to do it. You can get rid of the solutions items. I don't think we need that. There's nothing in there. So now, when I go ahead and build my project, we'll see that it will work, and I can set a breakpoint right here. Okay, so start debugging. Step over, and we'll see that now I have 3 in EAX. Okay. So that's what I would really recommend doing. If you want to then go ahead and work on the other file again for some reason, right, then you just kind of drag it down in there, and then you would drag this one up there. So I would always kind of keep everything in your ASM library and then just remove, exclude from project, the one you don't want to be working on. So then now I can go ahead and run this one again. Okay. All right, so with that said, let me again go back to my first program. So I'll drag that down there, remove, exclude from project, my add to.asm. And what I want to do is I want to just kind of walk you through really briefly a basic assembly language program that has a little bit of screen output. That way you can kind of play around with this stuff and test it out a little bit. And this will utilize the Irvine library. So what I'm going to do, I'm going to start off by just having, click on the right folder view here, so title. Okay, so I'll just kind of start off with a MASM template. I'm going to include Irvine 32.inc. I'll start off my data section, and maybe I'll have a particular piece of data up here. So I'm going to call this my name, or maybe my header info. Okay, I'll make this a byte. This is basically how I'm going to define a string. And so I'll say something like this: Dan Grissom, CS 340, project 1, or whatever I happen to be doing. Okay, I'm going to put a comma after that enclosed string, and I'm going to put 0DH and then 0AH and 0. Okay, so this is basically the quickest way to get kind of a new line character out there. That's all that 0DH and 0AH. That'll make more sense as you learn more about assembly, but for now, just kind of take that for granted. Okay, so I've declared my code. This is kind of have this .data little command to declare that I'm going to declare data, and then I want to say that the rest is code. Okay, so now that I have my code section declared, I can go ahead and say main proc. Okay, and you'll see the keywords are highlighted there. And I'm going to have a few commands. So I'll say move edx offset my header info. And again, don't worry too much about some of these keywords. You'll learn them later. For now, just kind of get the basics down so you can at least output some simple information. Okay, I'm going to say call write string. Okay, so basically this is going to write the string at whatever happens to be in this EDX register. Okay, if you want to do a comment, you can do that by using a semicolon. Okay, let's see. For some reason it's not highlighting. That should be green. Why it's not. Okay, so I'll have a comment here, and I will say something like print out header info. Should be green. Okay, so at this point you can see that this symbol right here actually tells me that everything on this line is a comment. You can see that the user data file that we kind of gave it for syntax highlighting, for some reason, I don't know if it's just not included in there or what, does not really understand that this is a comment, and it's giving us basically showing that these are errors. Let me go ahead and just finish this up, and then we'll see if it'll catch the comments, and if not, we'll go ahead and install that other syntax highlighter. So print out header info, and then the next thing I'm going to do is I'm going to basically print out a number, print out the decimal number in the EAX register. Okay, so I'm going to do that by saying I'm going to move something to EAX, so 15 for instance. Well, let's just do 123, something a little bit bigger, and I'll call write decimal. Now it's really usually a good idea to indent so you can kind of tell the hierarchy of things. So I'm just going to go ahead and indent all of these so we can kind of tell that, hey, all of this stuff is inside of the main procedure. Okay, and then you'll see that it'll actually kind of keep that indentation. Okay, and then the last thing I'm going to do, oh, I guess I brought it back. The last thing I'm going to do is I am going to then print out the registers. Okay, so I'm going to do that by call dump regs. Okay, I'm going to exit and then just kind of finish up this program. Okay, so I'll go ahead and hit tab, kind of get that stuff over there a little bit. And then you'll see it'll actually kind of keep that indentation in there. Okay. All right, so with that in place, let's go ahead and run this. It should run, even though it's kind of giving us these weird errors. So I can click on right click and build it. You'll see that it'll build successfully. And then we go ahead and start debugging. Actually, we want to not start debugging, but start without debugging. And you'll see it'll print out my little header, Dan Grissom, CS340, Project 1, print out the 123, and it'll print out what's in the register. So you can see that EAX in the registers looks different in hexadecimal than in decimal. But obviously, if we open up a calculator, go to programmer, right, and then we go to hexadecimal, we type in 7B, you'll see that in decimal that is 123. Okay. All right, so the last thing I want to do, and we should have done this earlier, but it does appear that we need both of those syntax highlighters. The first highlighter that we already installed from Kip Irvine's page will do extra stuff like highlighting title and some of these keywords that maybe were not caught by this new one we're going to install. But let's go ahead and open up, go back to our AsmHighlighter. So again, Visual Studio Gallery, just search for AsmHighlighter. Go ahead and download that, and I already did, so I'll go ahead and run it this time. And I will install it. Close. Okay, so again, I'm going to go ahead and close this. I'm going to go ahead and open up Visual Studio 2015. And if all goes well, recent projects and solutions. We will see that it still does not work. Oh yes. So the issue with this is actually the fact that this is a Visual C++ editor. It's expecting comments to be done in a different way, specifically for C++. So although, like we saw this code compiled with this semicolon, properly commented out this code, if we want to show that this is really a comment, the easiest kind of workaround is to simply put the / right after the comment, and that way it'll get rid of those ugly error lines. Maybe just move them somewhere else, which could be even worse. But hopefully at this point we should still be able to go ahead and build it. Go ahead and run. And we'll see our output right there. Right, so I guess at the end of the day, it's your choice. One of the many joys of working with assembly is nothing. And everything's just a little bit more difficult. So we get to decide, I guess, where we want to see the false errors, whether we keep them there on just the string. You'll see those will eventually go away, or if we want to see that those actually are strings very clearly, then apparently it thinks that these are errors, but they're not. All right, so with that, we've downloaded and installed Visual Studio and kind of got it set up to assemble Microsoft Assembly, or the x86 instruction set architecture code, assembly language. And we've created our first program using Kip Irvine's libraries. All right, hopefully that was helpful. Have a great day. Thanks, guys.